So there are 4 stations we need to hit. I'm going to say about 10 minutes at each. I want to give us as much time as we need, so we have until the end of the day to do this.
Yeah.
No, 10. Yeah.
10? The load is farther away, and the spring feels closer, so it has to be more effort. More effort. So is it? Does it change this time?
Yeah.
Did we reset it?
Oh, it was not 0. That's why there was a change.
Okay.
Let's try that one again.
One more minute, and then we're going to switch.
Okay, I'd say it's about 3.5. Can I try?
The incline. Okay, so let's go to lever. Start the day.
Let's stop.
When you do the
about
lever,
1.
Write your summary questions. Write your questions. I want you to reset if you've done all your testing and go to your science seats, and you can finish answering all your summary questions there in a group. But I think when you go up an incline, where we're going tomorrow, you're going to get this chart. We're going to fill it in together and talk about it. And then we're going to start we've done the asking. We're going to start imagining tomorrow as well. And maybe even start planning. All right. So today we are finishing up lesson 3. And in lesson 3 yesterday, you went and tried out 4 different simple machines. Technically, you could say 5 because you did a single pulley and a double pulley. And when you were testing them out, what were you looking at when you were testing those simple machines? What did you have to rate? Shar.
How easy it was to do the job, where you wouldn't hurt yourself, like ergonomics.
Ergonomics. So we looked at the ergonomics of the job. So how easy it is. Were you doing repetitive motions that could injure yourself? Or was it nice and easy on the body? And I'll tell you, if I had to bend over and pick up those potatoes today, I don't think my back could handle it. It's a little sore today. So the bending over all day would not be good. What else did we look at?
How much force it took.
How much force it took to do the job. And remember, so we talked about force. And then we also kind of briefly talked about this. What's the distance we moved everything? Allison? 6 inches. What fraction of a foot is 6 inches? Brooke? Half. So, if we wanted to calculate the work we're doing, we could use our formula to find out the work. We put in the force that we use times 1/2. Yes, Cooper?
Would the force be the number of newtons we use?
The force would be the number of newtons. And then the distance is in feet. So we're dealing in feet. So we're going to look at that as we work. So now what I want to do is I want to look at our results. So I want everybody to open up their notebooks to the pages, our notes that you took. So we're going to come up with a class results. So for example, we all have the same results for the load. So if you look, how many newtons of force did it take to move the load by hand? So we did this together. I demonstrated it for you yesterday. So when I just did it by hand, for the lever, it took 5 newtons, correct? For the long board and incline plane, it actually took 5 1/4. For the single pulley, double pulley to move that distance, it took 5. How much I don't remember off the top of my head, the cart.
No.
1 1/4. So 1.25. So those are what we would say our reference points. That's what it takes to do that job with no help, with no simple machine giving you some advantage. Now let's talk about the scale reading. So what I'm going to do is I'm going to go around and have each group tell me what they got for readings. For position A, what did you get?
We got 2 positions.
So 2. Let's practice saying it in the correct mathematical language. So 2 and 25 hundredths. 2.25. Divide by 7. We get 2.21. So, looking at our chart, I want you to leave this page open. And I'm gonna ask you some questions, okay? So thinking about the 3 levers. And these are your summary statements too, so if you want to look at them. But which relationship between the position of the lever and the arm and the amount of force needed to lift the load? Which one felt the easiest to do? A, B, or C? A. So A worked really well. So we would say that this one is probably a check plus. How about B? Check. And then C? Check minus, or I'd say 0 credit. You know what I mean? Like you wouldn't, there's no advantage to using, well, what's the advantage to using that one? It makes a longer arm, so it gives you longer strength, but there's no force benefit. So now, with the inclined plane, you have the short board and the long board. Which one would you give the check plus to? And check plus means least amount of force. AJ, the long board. But I'd probably give the short board a check too because it decreased the force as well. It went from 5.25 to 3.64. So there was a decrease, so it did give you some advantage. Remember, we were talking about the word mechanical advantage. And mechanical advantage is less effort for the same amount of work. That's your dream come true. You'd love to be able to get A's and have to do less work in 5th grade, right? It's not going to happen. So, now your pulleys. Did the single pulley change the amount of force at all? No. What does the single pulley do? What does it change? What would be the benefit of using a single pulley?
Instead of them being able to pull it up.
You get to just pull it down. So a single pulley changes the direction. A double pulley changes the direction as well as decreases the force. So the force will go down. How many people are starting to think about ideas for their subsystem of what machines they want to use? How many people kind of have a plan already formulated in their head? Okay, good to know. Good to know. All right, wheel and axle. This one I feel like is obvious. Which one was the best one? The one with the wheels. It is common sense. So again, to recap, how do simple machines make a job easier?
Well, they trade a distance for force.
It decreases the amount of force required to do a job by making it more by making it more comfortable to do. So for example, the pulley makes it more comfortable. It's so much easier to pull something down than to bend over and pull it up, okay? So what we are going to talk about now is, we're now starting lesson 4. Ooh. I like this lesson. I will say, for simple machines, I don't do a lot of pre-teaching before the unit starts. I have a PowerPoint that we do. We go over them. We talk about it. That's about the gist of what we do. This lesson takes what I talk about in theory and puts it into practical knowledge. And when they leave this lesson, they really have a strong idea of how each simple machine works and why it's beneficial and why it's not, as well as what the mechanical advantage is of that simple machine. This lesson is probably one of the most labor-intensive lessons to set up, and the materials and making sure that they're in order. What is nice is once you have them set up, most of the time they're set up, you don't have to recreate them. And then having the space for it to work can be challenging because I'm in a smaller classroom, so you definitely have to just kind of plan ahead of time. I did find that it is really important to read this lesson because the whole part of this lesson is it has to be standard and uniform between every station. So every potato or water bottle needs to move 6 inches. If it goes more than 6 inches, you're gonna have different results, and then the kids are gonna find out different things, and it's not gonna show them what you're looking for. And I actually will go through and show them how to do every single one, and we'll record the standard of how far the water bottle moves without the simple machine together. So that way they all start at the same place, and then if their numbers vary, it's not as huge of a vary. Also, one important thing is teaching them how to zero the spring scales, and that I will say is a challenge, and it's not a challenge because they're hard to do, it's just a challenge because they're 5th graders. They don't want to necessarily be perfect. So I always try and emphasize the fact it has to be on 0. You have to check it every time you go to do it, because if you don't, it'll be off and your numbers won't work. Depending on my class size, usually I have between 22 and 20. I had 28 students last year. I usually try and do groups of 3 and 4, because I feel like if you go any more than 4, you have a lot of fighting. And I like the groups of 3 because usually you can have a majority vote. With this lesson, I find that the follow-up has to be very much planned out, and you have to know what you're talking about to make sure it's clear for everybody else, for the kids, because you want them to walk away understanding.